Welcome to this Winemakers Research Exchange presentation. Today we will be discussing an experiment comparing different methods of measuring malic acid in juice and wine. The purpose of this test was to determine the accuracy, precision, cost, and ease of use of enzymatic kits and the Sentia wine analyzer in production wineries using samples that represent key points when malic acid might be an important determiner of winemaking operations. My name is Joy Ting, and I'm the research enologist for the Winemakers Research Exchange. I'm joined today by the three winemakers who participated in this experiment. The first experimenter is Kirsty Harmon. She's the general manager and winemaker at Blenheim Vineyards. Welcome, Kirsty.
Thank you so much.
So, Kirsty, tell us just a little bit about why you were interested in doing this test.
I was interested in doing this test because I've purchased a Sentia primarily for measuring SO2, but I was really curious to see how it would perform with malic acid. I generally do malic acids by enzymatic assay, but the ease of use of what my experience has been with the Sentia made me really interested in using the same tool for multiple analyses.
Great. So one of the reasons we chose the experimenters that we did for this is that we have kind of a range of different backgrounds and training with regard to laboratory analysis. So Kirsty, do you have any formal science training?
Yes, I do. My original career was a microbiology lab, and so I worked for a number of years in yeast genetics before I decided to make the switch into winemaking.
Right. And how long have you been doing enzymatics in the winery?
16 years.
Okay. And with your Sentia, you also have a Sentia, and as you said, you use that for SO2. Have you used it for malic acid prior to this, or was this sort of your first run with malic acids?
I had been given a test kit to sort of just play around with, but this is my first real serious set of experiments with Sentia for malic acid.
Great. So Kirsty's sort of like our expert user in that regard. So at least for enzymatics. So our second experimenter today is Matthieu Finot. Matthieu is the winemaker at King Family Vineyards. Matthieu, why were you interested in doing this test?
Because I also do a lot of analysis in-house, and I have to say I'm working with Enzymatic most of the time, and I don't like to do that. So I was trying to see if there's an easy way to do it.
Great. And so do you have any formal science training?
Yes, but no. I mean, I've been in winemaking school, so I've studied to do like the basic lab analysis. But no, I'm not a scientist.
So you're a good example of somebody who does a lot of analysis in the winery lab, but maybe doesn't have formal training outside of that.
No, I mean, I've started working with micropipette very late in my life, so.
And then you also have a Sentia, so tell us what drew you to that, and how have you been using it so far?
I was trying to initially find an easier way to do sulfur and to get a more immediate answer and faster way to do it. That also not only me can do it, but anybody else in the winery can do it. So it's fairly simple to use. And the result seems to be fairly consistent and in margin of what I consider acceptable. So I've been using Sentia since then.
Great. So our third experimenter is AJ Greely from Hark Vineyards. Welcome, AJ.
Morning or afternoon.
So why were you interested in participating in this experiment?
Well, number one, you asked me to. So
because you're a good sport.
And it's also for ease of use and time. Running the enzymatics always is a time-consuming process, especially at the number, at the rate that we run MLs. Because I run MLs on individual barrels, not just on composites, and so. For ease of use, as a smaller winery, I think it's having enzymatics has been great. However, looking at something that would be slightly cheaper to run, faster to run, especially because, you know, I'm the only one who's running labs. So
Yeah, great. So do you have any formal science training?
oh no. No. I was an English major with minors in theater, history, and philosophy. So not even close. Yeah.
So, and then so you do run some enzymatics. How long have you been doing enzymatics in your winery?
For 3 years.
Okay.
Since
Pardon, since
2020.
Right. And I will say, I mean, you also do run a lot of the wet chemistry. I know that, you have a great attention to detail. You run wet chemistries for your SO2s and for your like pHs and that sort of thing. But in this case, you're relatively new to enzymatics.
Yes.
And then you don't have a Sentia of your own. Sentia was kind enough to lend us a device to use for this experiment, but you do have a little bit of experience with Sentia in the past. Tell us just a bit about that.
I think it was it 2020 or 20? I think it was spring of 2020, where we ran the SO2 experiment in conjunction with Rachel at Stinson and Phil at Whitehall, just seeing the accuracy and ease of use and efficacy of the Hannah titrator. I think we talked about doing enzymatics, but we never did. Running AO and then running the Sentia. And so I had a borrowed Sentia for that one.
Right. So each one of our experimenters has a little bit of experience with some experience using the Sentia with SO2, but very different experiences with regards to pipetting. So as we jump in today, I am going to show you a little bit about the setup of the experiment, and then we'll go through the results, and then we'll bring our winemakers back and hear their comments on what it was like to use each one of these approaches. So let's see. Okay. Hopefully we can see these. Oops. There we go. So when we're looking at kind of trying to find a method to use in the winery, we're interested both in the accuracy and the precision of that method. So when we talk about accuracy, we're just talking about how well the measurement that we get with our methodology lines up to the true value of what's in there. So how close is our malic acid number to the true amount of malic acid in there? For this particular experiment, we decided that when we set up our samples, when we brought the samples to our experimenters, we also sent a set of those samples to ETS, which is a service lab in San Helena, California. ETS has been running these things for a very long time. They have numerous accreditations, and they're really considered to be the gold standard in wine analysis. So we thought that was going to be a good measure of accuracy. But in addition to accuracy, we're also interested in precision, and that just tells us how close multiple measurements of the same things are going to be to one another. Precision is really important to us as well, because most of the time we're only running one test at a time. So it's not, most of the time our experimenters for this ran ran the same sample 6 different times. Most of the time in the winery lab, we're not doing that. We're running a single test. So we need to know every time we do the test that we're getting relatively the same answer. So one way to kind of look at that is sort of looking at our graphic here. If we consider the darts to be our different malic acid results from the same sample, and if we think of the middle of the target as the real number, if we have a result that comes back something like our bullseye A here, we can see this is neither precise nor accurate. Even if we take the average of all of it, it's nowhere near the actual value, and any one dart doesn't really tell us much with regard to where the other darts are going to be. If we look at B, that one's precise, but not accurate. So every time we're getting just about the same answer, but it's not really close to the real value. C, it turns out if you average them all, it's good and accurate, but unfortunately, no one of those darts is close enough to really make an estimation that we would want to make a decision of. We're really looking for a method that looks like D, that's both precise and accurate. It's going to give us a measure almost every time that's pretty close to the real value. So all of the methodology that kind of gets rolled out into the winery really has been developed to get as precise and as accurate as possible. But of course, there's always multiple sources of error that we need to think about that might cause our values to be further away from the true value than we want them to be. So when we think about sources of error in our malic acid testing, there's kind of two different types of error we might want to think about. The first of that is just sort of the setup or the error rate of the error that's inherent to doing that test itself. So all of these tests, whether we're using the Sentia or we're using Enzymatics, those are kind of based on some kind of algorithm or equation that turns the number from the spectrophotometer into the number that tells you how much malic acid you have, for example. So those algorithms or equations might have limits after which they really aren't as accurate, for example. We also have to think about the calibration of our own equipment. So both of these methodologies use micropipetters. So we have to think about the overall calibration of our micropipetters. And our spectrophotometer matters quite a lot as well. So different spectrophotometers have sort of different qualities in terms of how consistent the results are going to be that you're getting back from that. And then lastly, we have lots of solutions that come. So the companies prepare these solutions at their manufacturing facilities. There may be some variations in that. They get shipped to us in all manner of different shipping conditions. And then, of course, it's how we're storing them in the winery itself. And all of those things can introduce potential error along the way. And that's all before we start to actually set up the test. So once we set up the test, there's all the kind of human error kind of things that come along as well. And no matter how experienced you are or what a great lab researcher you are, there's always the potential for human error. So if you've ever set up enzymatics in the winery, you know that there's lots of organization that comes along with that, having all the little tubes set out and keeping track of which one did you add your sample to and which one did you not add your sample to. There's the potential for interruptions, and we've already heard a couple folks talk about the amount of time it takes to do these. Well, the longer the time there is, the more likely you're going to get interrupted in the middle. And then there's just the overall expertise with using these methodologies. And I think particularly here that the precision and technique of micropipetting becomes pretty important, especially with our enzymatics. So any of those might be contributing to differences in accuracy and precision as we go along. So to give you an idea of how we set up the test, each of our experimenters, as I said, ran 4 different samples, 6 different times. But they didn't really know what the samples were when we gave them to them. So when we set up the test, basically they received little tubes with coded numbers on them and were asked to run those samples in a particular order. So for each testing session, they had 8 tubes that were going to get tested with Sentia and 8 tubes that were going to be tested with Enzymatics. We did that 8 at a time because that tends to fit into a good size for the enzymatic run if you have 8 samples plus 1 blank plus 1 standard. So for each of those 3 runs, then they would also note the time of starting and the time of ending, so we would have some idea of how much time it took to run all of these and be able to compare between them. What our experimenters did not know is what they were actually testing. So if we look at kind of what was being tested along the way, we again had 4 different types. We had a juice, we had a white wine, and then we had 2 different kinds of red wines. And the way that we arranged these with each testing session was that at each testing session, at least each type of sample was run at least twice. So for example, if we look at run number 1, we can see that red wine number 2 was run twice in the Sentia testing session and twice in the enzymatic testing session. We also set things up so that everything was tested in at least 2 different testing sessions. The reason we did that is that, especially with enzymatics, you might expect to have a little more variation between testing runs than you would within a testing run, just because of some of the potential sources of error. So again, in run number 2, we once again saw red wine number 2 in both of those at least twice. So for some of these, they were actually run in all 3 different testing runs. Some of them were run in 2 of the testing runs. And I'll show you what that means when we look at the data moving forward. So all of the graphs that we're going to look at today are going to look the same. So this is one example, but all of them look this way. So for each one of these, we've actually represented each each result with one of the dots on the graph. So we're showing you all of the data here. The dots are color coded. So anything that was done in run number 1 is in blue, and run number 2 is in orange, and in run number 3 is in green. And then we also put the number from ETS, whatever ETS measured this to be, that's what's your sort of red dotted line that's shown on each one of these graphs. So our enzymatics are always going to be on the left-hand side, and the Sentia is always going to be on the right-hand side. So for this particular example, the first sample that we'll look at is juice. And the reason we wanted to include juice is because that's one of the places where somebody might be making a decision, for example, about acid addition. So if you have something that comes in that's a very high acid, you might want to understand how much malic acid is there that might get converted into lactic acid along the way. If it's a white wine sample that's not going to go through a malolactic, you might want to know how much malic is there, probably because of the sensory impacts of malic versus tartaric acid at that point. The juice sample that we used in this case came from Cabernet Franc grapes that had been turned into juice, and we had that frozen in the freezer here at the Research Exchange for another experiment. We had some left over, so we had a juice sample available for this particular run. So if we look at this, the first thing that we can see is that neither the Sentia nor the enzymatics really were able, basically almost all of the runs underestimated the amount of malic acid that was found in these samples, with the exception of experimenter C's juice sample, Sentia sample. Now, one thing to keep in mind here is that each of the tests that we're running does have a limit of detection of the test. When we look at Sentia lists the limit of detection, their upper limit, as 4 grams per liter. So this should be within the limit of that test. Experimenters A and B were using the Vintessential enzymatic kits. Those don't really list an upper limit, but they do say that you need to do a dilution based on how much you expect to be there. And the standard dilution that they give you is for 2 grams per liter as the upper limit. Unfortunately, you don't know that you're above 2 grams per liter until after you've run the test one time. So if you really wanted to key in on this, you would need to rerun the test with a different dilution. The Unitec, experimenter C is using the Unitec kit. There's actually 2 Unitec kits for malic acid. One has a limit of detection of 1.5, and one has a limit of detection of 4 grams per liter. And again, in this case, I think we used the 1.5 kit, so we were probably above the limit of detection there. Unfortunately, when we run our juice samples, we don't know if we're going to be above or below that. And so in some cases, maybe to key in on this for our enzymatics, we'd have to actually do a little bit more dilution. Now, when we look at this for precision, we can see that in general, the Sentia looks like it has higher precision than what the enzymatic does in this case. And we'll look at some numbers for precision once we look through all of the sample data. So when we look at the white wine sample, again, we wanted to include a white wine sample with relatively high malic acid, because again, that tends to be when we care about which acid is causing the acidity in our white wine, tends to be when it's a pretty high malic acid sample. So the white wine sample we used came from a Petit Manseng produced at Hark for another experiment last year. In this case, the ETS value was 2.6. And once again, we see that each of our methods really underestimated that number. I will say we also sort of see the biggest spread in terms of precision here. We can see that we do have both experimenters B and C with their enzymatics have a spread that can be almost as much as, between 0.5 and 1 gram per liter difference, which might cause a difference in interpretation of some of the acidity in that wine. We also have experimenter C. The Sentia device did seem to have some sort of some consistent problem there that was consistently underestimating that volume. And that was true for all 3 of those sampling runs. So that would lead us to wonder if there was maybe something else going on in that particular case, whether there was maybe one of the pipettes is not well calibrated, or if there's a problem with one of the testing solutions that looks like it's consistently lower. It's very precise, but it's consistently below the target value. If we look at the pre-malolactic red wine, we wanted to make sure to include a red wine before it went through malo, because this is another time where a winemaker might want to know the malic acid content, particularly if you have, let's say, a high pH at that point, but you want to know how much malic acid you have left in order to understand how much your pH is going to shift with malolactic fermentation. I will say this was kind of a tricky sample to find as we did this experiment in the late spring or early summer. All of the reds had already gone through malolactic fermentation. So what we ended up using was a port style Finot wine from Michael Schaap's Wineworks. This is a wine that's produced by basically fermentation is arrested with residual sugar prior to the end of malolactic fermentation in order to preserve that residual sugar and to add a fair amount of alcohol to get to that port style wine. We did check with the company to make sure that the sugar and the alcohol were not going to interfere with the testing itself, the malic acid testing. I have to say, this is an example where the Sentia really shines. We can see that the Sentia values are very close to the target and they're very precise. I would also say that Sentia, from my understanding, is based on an algorithm that they're continually refining. But if we look at this particular value, this is the one that kind of sits right in that sweet spot of where most of your values are going to sit. So probably the algorithm is very strong in that particular spot. Unfortunately, our enzymatics did not do so well in this case. So experimenter A still had a very accurate and precise response, but experimenters B and C, we do see a fair amount of spread in those values. I think if we look at the experimenter B, this is a good example, I think, of one of the, it looks to me like one of the things that we can often see with enzymatics is maybe when you're adding your sample, you either added twice as much sample on the upper blue dot, or missed a tube when adding that sample with that lower green dot. And that's really one of the things I think with enzymatics that's hard. If you have a whole bunch of tubes all in a row, sometimes it's hard to keep track of which one has actually gotten dosed with whatever it is you're dosing with. And then experimenter C with the enzymatics, I think we can see that the first run went very well, but subsequent runs we did see some drift in the results there as well. And then lastly, if we look at our post-malolactic red, this is probably the most important one. This is the one where we're making a decision that we essentially can't take back. We use this post-malolactic number in order to see, is the malolactic fermentation all the way complete? If we get a number that's artificially low, we might sulfur the wine too early. If we get a number that's artificially high, we might not sulfur the wine. We might take on extra risk by not sulfuring the wine as soon as we might want to. The first way to look at this, I kept this graph here because it tells us that relative to the other ones, we can see that if we keep the same scale on the graph, this looks very precise. All of the lines are right in a row. Everything just looks right on. Unfortunately, the sample that we're sending in the decision point for us is really compressed at the very bottom of that graph. So I did sort of do another graph where we zoomed in. So this is all the same information we just saw, but we just see that the x-axis there, we've kind of expanded it out so we can see what all those little numbers mean. Because with this particular example, this is where a difference of 0.05 might make a difference in terms of our winemaking decision. In this case, the ETS sample was less than 0.05. So it means that it was below the level of the detection of the ETS test. And what we can see here is that our enzymatics do a better job of getting close to that approximation than the Sentia does. We can see a kind of a little bit broader span in those numbers with the enzymatics, but in this case, it does a little bit better. We continue to see some sort of an issue going on with experimenter C with that particular set. It's still relatively precise, but all of those values are shifted up, which again makes us wonder if there's something going on either with the device, with the pipetter, or with one of the buffers along the way. So given all of that, we've seen sort of how we're doing in terms of accuracy. There's one other way to look at precision, and that is by looking at the coefficient of variation. This is basically just calculated by taking the standard deviation and dividing it by the average of all of the samples. But we can really think about that as kind of the range within which the true value probably is. So if you get a malic acid number of 0.3 and your coefficient of variation is 0.1, it means you're probably about 10% plus or minus your 0.3 in that actual number. So if we sort of compare our coefficient of variation for each of these testing methods with each of the wines that we just looked at, the juice, the white wine, and the red wine with malic acid sample, we can see that the Sentia device really does give us a lower coefficient of variation in most cases. Again, experimenter A, who's our expert user, has a very low coefficient of variation with both approaches. But without quite as much scientific training, the Sentia does really give us a nice coefficient of variation really across experimenters. The post-malic red numbers, you might notice, are much higher if you sort of look at the numbers on the left or on the x-axis there. That's much higher just because of the way we calculate that number. We calculate that number by dividing it by the average. And in this case, our average is a very low number because we just have very low amount of malic acid. So I would say a better reflection of the coefficient of variation is with those other three that have a more normal amount of malic acid. So one other thing we wanted to look at in this test was looking at a cost comparison. How much do each of these things cost, both for startup and the cost per test? I didn't include paper chromatography and the service lab in there because a lot of folks are using one of those two other options. But if we zoom in just on the Enzymatics and the Sentia, the startup cost for Enzymatic is a little bit more because you do have to buy a spectrophotometer to make this work. And I would say the quality of your spectrophotometer probably does have some impact on the accuracy of your results. Once you have that spectrophotometer, the cost per test is probably about $4.75 or so, depending on how many you run at one time. With the Sentia, that's currently pricing at about $2,500 for the device. With the test strips and the buffer, it's pricing at about $7.20 per test. In both the cases of the spectrophotometer and the Sentia, that device, the spectrophotometer and the Sentia device can both be used for other things as well. So it's not just a purchase just for this one test, but it is an upfront purchase to get that done. And then the last thing that we'll look at here is looking at how much time it took people to do things, because again, that's a very, if the price of the thing is not the limiting thing or the limiting portion of the decision, sometimes the time it takes to do the test or the time that the winemaker has to do this is important as well. So what we can see here is that for each of our experimenters, the Sentia took less time than the Enzymatics did. In this case, again, experimenter A is our expert experimenter, and there is some sort of efficiency of sort of being used to how to set all of these things up and knowing how to get them done. Those pre-testing organizational steps sometimes take a little bit longer if you don't do them a lot, if your lab isn't set up to get that done. And I think that's what we see reflected in Winemaker B and Winemaker C in this case. And then the last thing we'll say is that, in the course of doing this experiment, Sentia did actually send out some additional materials in terms of just things to make sure that you get the best result possible. And I wanted to make sure to point these out as well. These are available on their website, but they've issued some guidelines in terms of how to best do the dilutions to get the best result. That portion of the website also has some really good guidelines in terms of how to store the solutions and how long after the dilution to do the testing and those sorts of things. So I would anticipate that as more and more people are using Sentia, that these will be refined in a way that give us very good, clear guidelines. I would also say that they're based on an algorithm, and that algorithm has already been updated once for malic acid. And with additional testing, if they do update that algorithm, it's just an update into the device. So it is something that if you own one of those devices, you continue to kind of benefit from the refinement of the protocols themselves. Okay, so with that, I would like to go back to our winemakers and talk a little bit about just your experiences with these particular with these methodologies. So I'm just curious what what feedback you all would have in terms of what you liked about if you liked what you liked about either one of those methodologies, or if there was something you particularly didn't like about one of those methodologies. I know you all have opinions.
Really? We do? Go first, Kirsty.
I found I'm comfortable with using Enzymatic, so that's what was a very comfortable thing for me. I've done hundreds of them each year, so that was no problem. But I was reminded after using the Sentia for a short amount of time that it does take a lot of time and effort and concentration to do a good job. So I liked the ease of use with Sentia. It was one dilution, and then you drop a sample, and then your answers are there. I think what was made clear to me is that never in the history of doing these samples have I done as many repeats of the same sample. So I think it's just a good reminder that you get one answer, or you do one test, you have one answer. You might want to double check yourself once or twice with whatever method you're using. I think it's just a good rule of thumb. So I found the Sentia pretty straightforward. I probably won't miss doing enzymatics in the future.
So that difference in the cost per test is not something that's worth it to you. Like,
I'd have to think about that over a whole season, because I was buying a kit of 100 for the Vintessential analysis. I think the savings of time is worth the increase in cost. I just need to I think everybody needs to feel assured, though, that the numbers they're getting are actionable, right? That the number you're getting from the result and the action that you're taking based on that result is the correct one.
Yeah, that's a good point.
Yeah, I will say on my side it's about the same. I had to do like the enzymatic after hours. That was the only way I could have run it without being disturbed, because I always have somebody popping up in my office and asking me a question. And so for me, the Sentia, I can do it whenever I want, and there's not a problem. I can also do it just for one sample. When I do the enzymatic, most of the time, if I don't have like at least 5 samples to run, I'm not going to run the enzymatic, because I feel I'm wasting I'm wasting a lot of product just to run one sample. So I feel like the enzymatic works if you've got more than 5, I will say between 5 and 8 samples to run, then it makes sense to do the enzymatic. But then I have to do only that for 55 minutes. So it's an hour of my time that I have to do without being disturbed once, because otherwise I don't do it right. And then I have to run it again. And even when there were one that I knew that I messed up when I've done the experimentation, but I had no way to rerun it anyway. I didn't have enough juice to do it. But even if I wanted to rerun it, then it would have doubled the time. So you go from 1 hour to 2 hours to run your, it's too much time in my day. I feel like the Sentia, if I'm not sure if I've done the right dilution, I'll redo it, but it's just one sample that I redo. I don't have to redo the whole flight, I would say. So the difference of cost for me is not that important because of the time. I mean, Kirsty is much faster to run like the enzymatic. So I feel like, she can rerun it much faster than me. For me, it's too time consuming. And yeah, I feel I'm more precise ultimately at the end. Most of the time, by the way, I'm doing paper chromatography for most of my reds. It's very rare that I really need to be that precise anyway. But sometimes you want to know, or you want to check one especially, or for me, it's more just when I want to know what's my Malic at harvest. That's where it's most important. And again, during harvest, very often you don't have much time to dedicate to run enzymatic when your lab is full of people and juice and things like that. So I feel like the ease of Sentia is important.
So when you're running that on juice and during harvest, we did see that basically both of the methods are underestimating what that actual juice Malic is. Is that concerning to you, or is that difference not enough of a difference and it still kind of gets in the ballpark of what you would be making it like? How fine-tuned?
I don't have a true benchmark, but basically I want to know if I'm like at 1.5 or 2.5. So it's and ultimately on the long run, it's more having a consistent, as long as I'm consistent with the results that I get, doesn't matter if they are in some way accurate, as long as they are, I mean, they can be accurate, but like if they're not very accurate, doesn't matter. As long as they, from year after year or vintage after vintage, they give me a result that is always, you know, that your bull eyes and things like that. But
that's where the precision comes in, right?
Yes.
Is that like, if you're trying to track a trend, precision is
Yes.
still an important consideration.
And I feel I had the precision with the Sentia. Maybe not completely the accuracy, but there was a precision.
Right. Good. How about you, AJ? What do you think?
Well, considering I'm the one who had kind of the most variation in my with my Sentia, I'm not convinced yet. It is, I think Matthieu is, you know, I take more time than Matthieu. So running on Enzymatic. So running Enzymatics, it's a day thing for me. It's a day I set aside and I'm like, all right, we're going to pull samples on everything. And then I'll, you know, run a bunch of Enzymatics. It's day and a half for me to do that because, you know, it can be 40 barrels. So it would be nice if we can get actionable detail or data from Sentia, but I have to wait for that. And it does become a cost thing for me too. I mean, we are smaller and we are currently cost conscious here at Hark. And so that $7.20 a test versus what I'm doing with the Enzymatic does make a difference. So.
Yeah. Well, and I think that's a good point too, is that like, it depends on how much margin you have in your daily working life, how many other plates you're spinning and how able you are to kind of be to separate out, you know,
Yeah.
what's happening. I will say each one of you, your lab and your office is the same place. But it's also where like the rest of the crew will come in and have lunch. And it's also kind of a busy place. And so that I think is something to keep in mind in terms of kind of when it makes sense to do enzymatics. A lot of times it's harder to kind of keep everybody out because it's more of a community gathering place and you're more likely to get interrupted. So that makes a good point along the way. So for somebody that's like deciding whether they want to buy a Sentia or buy a spec, or if they want to bring this in-house, does anyone have any other advice to give to your fellow winemakers who might be thinking about that?
I mean, for me, it's easy. I'll recommend to buy a Sentia because most of the time that's also the thing is like you have to be good at micropipetting when you do when you do the enzymatic, and by having a lot of interns during harvest and things like that, I know that not everybody's got the same skills, not everybody's got the same precision. I'm even surprised that I was that accurate doing it because I hate doing enzymatic because I have to be so focused about it. So I feel like there's less chance of error with the Sentia than the enzymatic. So for me, it makes sense. Again, when it comes to the price, I never check every individual barrel anyway for my Malic. I always work by batch. So, and I'm going to run the paper chromatography first. So if I really have a doubt on a batch, then I will run the Sentia. Then I will try to get a real number of Malic. But I think there's a way to cut down in cost by using the chromatography paper. And then at the end to have confirmation that you're dry, you run your Sentia. Then you don't have to spend $7 every time if you want to know where you are into the malolactic fermentation. So I think like the combination for me of chromatography plus Sentia is a very effective and cheap and can be run by everybody because it's very easy to run chromatography. So I feel like it's two methods that get me a fairly accurate result if I want to know if I'm dry or dry. If the malolactic fermentation is done or not, it's fairly accurate, it's not too expensive, and everybody can run it.
Right.
I think if we had not, if I was making this recommendation to somebody who had not yet purchased a spec, then I would tell them to lean more towards the Sentia meter. I think I would have I would have weighed the difference between Sentia and the spec if I didn't already have an enzymatic. If I didn't already have an enzymatic spec, sorry, talking about.
You're illustrating the point though, right? Is that like it's
They
a busy
are.
place,
Like,
right?
people coming
I think
in
this is the point that we
around
all
the
like.
office.
Imagine if you're doing
Yeah.
Enzymatic right now, right?
Yeah. And so we are, I guess doing this makes no sense to people.
Yeah.
So, but if I hadn't already had the spec, if we hadn't laid the money down, and that was only 3 years ago, so it's relatively new, then I would consider a Sentia instead of a spec, especially for ease of use, and especially if you haven't used a spec or enzymatics before.
Yeah.
It just makes better sense.
Good point. Yeah. Anything else? Kirsty, do you have anything to add to that? You sort of.
No, I agree with what has been said. For ease of use, the fact that you have crazy good pipetting skills, and for me, because I know the Sentia can do other analyses as well, not that a spec can't, but I am able to do more of my lab work in a short amount of time. So
Yeah.
the Sentia would be my choice.
And that's a good thing to bring up. We've mentioned the SO2 and we've mentioned malic acid. And since we started to plan this, Sentia has come out with acetic acid. We've got glucose and fructose now. And now there's also titratable acidity. As of yet, there's not a YAN, so we don't have a nitrogen measure quite yet, which would be something else you might still need to do elsewhere. But we certainly have seen a lot of capability coming online with the Sentia in the last couple of years. So,
and if we want to talk about, like the acetic acid, when you do the acetic acid with a spec, that's even more time consuming, because I think the waiting time, it's even longer. I mean, you have to wait more with each pipetting. So it takes, for me, even longer to do the acetic acid with Enzymatic. And
so you're saying you don't want to do this experiment for us with acetic acid?
No, absolutely not. I will not do it. I'm saying it. So it was horrible for me. It was torture. But what I'm saying with the acetic acid is I feel it will be even longer for me to run the stuff, and I think I will have more chance of not being precise. I feel like the Malic in Enzymatic, it's the easiest run to do. Yeah. So the acidic is even more complicated. More chance of not being right. And I feel for me, like, again, like having a Sentia now, I can run, like having this reanalysis, the sulfurs, the acid acetic, and the Malic is all what I need, and that justified that I can retire my spectrophotometer somewhere else in the winery, create some space on my workbench, and be much happier in my life.
Well, and I think you make another point is that when, at least the kits that I used to use, the malic acid had essentially the largest, like when you were adding your sample, which I think makes the biggest difference, it was sort of the largest amount. The other ones you had less. So when you're adding your sample for malic, it was like, I don't remember, like 30 microliters or something like that, where others could be 5 microliters. And there too, your margin of error gets pretty, you get it. It's a lot easier to make a mistake with that, with having our pipettes maybe not do as good a job as they need to be super accurate. So that's another good point.
The other thing to consider too is, like with the Unitech spec that I have, when I do MLs for reds, I have to decolorize before I dilute.
Yeah.
So, and that's
another whole nother step and a whole nother
space for error.
Yeah, that's a good point. Well, thanks to each one of you for being willing to do this. I realize, as Matthieu has pointed out a few times, this was a lot of work to run a lot of replicate samples, but I do think it was really useful to see what kinds of differences we might see between runs and between samples. So I really appreciate your efforts in doing that. We also want to make sure to thank Sentia, who provided all of the strips and the buffer solutions and a device for AJ to use. They were very helpful as we kind of tried to put together this experiment and helping us to realize what the device is good to use for, and and how to structure that. And we also, of course, always want to thank the Virginia Wine Board for continuing to fund the Winemakers Research Exchange. So we'll also say that this will be written up into a report and put on our website. So if you're kind of seeing this as a YouTube video or through your email, the full report, if you want all the numbers, you can get the full report off of the website. So thanks, everybody, and happy harvest.
Thank you.
Thank you.